Hello, data lovers. It is Merdad. Welcome to my channel and another episode of Azure Data Fundamentals course, which is related to the data processing. That here we will compare the transactional data processing and analytical data processing. So if it is for your first time that's seeing my channel and this video, there is a playlist for Azure Data Fundamentals course that you can find it in the playlist. So let's unpack today's session. So when it comes to data processing systems, we encounter with two concepts, which is related to the transactional data processing or operational data processing and analytical data processing. Let's discover what these guys are going to offer to us. For transactional data processing, which is basically mostly considered the primary function of business computing, when it is going to record the transactions of events that are happening in an organization, and the organization wants to track them. So some examples could be, transferring money between banking accounts, or completing a sales order in an online shop, or when you want to register for online course, right? Each of them are going to be called as a transaction. So basically, the number of transaction records in a transactional database is in the high volume of records. For example, in the banking industry, in the banking databases, we may have millions of records per day. And so it has to process that data very quickly, and it should be accessible for referencing, for online reporting. And at the end, I should just mention that the work that is going to be performed by transactional systems are basically referred as to OLTP. What is OLTP? Let's jump into the next slide, which is going to talk about OLTP, online transactional processing. That is basically a solution rely on a database system that basically is optimized for read and write the transactional data that is going to support the transactional workloads. And basically, the read and write that we are talking about are referring to the operations, the normal operations in a transactional system that is going to be including, create a record, retrieving the data, and updating those records, and also deleting. And as a short, we call them CRUD. Basically, OLTP systems came to support, live applications that they need, to have the transactional data for, for the business data. Or in the other word, we call them LOB, which is a line of business applications. And to achieve the data integrity in transactions, OLTP enforce the transactions to support asset semantics. What is asset? Each letter just comes for this concept. A for atomicity, and C for consistency, I for isolation, and D for durability. Let's uncover C and see what is asset. But before explaining asset, I would like to just show you two different transactions that we will just bring them to asset, and see how it is going to impact on that, how it is going to work on those transactions. Transaction number one is money transfer. So let's just cover what is the steps of this transaction. So at the first, the requester is going to send the money, right? So it is request to send money. Then the bank is going to check the authentication firstly, of course, and check the balance. If it is enough, then the next step, check the destination account if it is valid one, and then it is going to do the transfer, the amount. So that amount is going to be added to balance of the destination account. And after that, that amount is going to be deducted from the sender account. And at the end, it is going to have a complete transaction. And transaction number 2 will be a short transaction like tracking, actually checking the balance of the amount in the banking account, which we will request the balance and then check the authorization and show the balance. So let's see what asset is going to do with these transactions. The first letter, atomicity, that says each transaction is treated as a single unit. That, for example, for money transfer, all steps that we talked about is a single unit of transaction. So all of them has to be succeed or all of them has to be failed. If something, for example, fails in the middle of this transaction, the destination account is not valid. It is failed in the midway, and so the whole transaction will be failed. The next one will be the consistency that talks about, the transactions can only take the data from one valid state to another. For example, in money transfer, the amount of the balance in sender or in destination is going to be changed from amount X to Y, and so it is a valid state that is going to be set to the system. The third one will be the isolation. But for the isolation, what does it mean? We may have concurrent transactions that are coming to the that banking account, software or banking account, that they should not impact one another. So when a transaction is running, for example, when a money transfer is running, the next transaction, which is checking the balance, should wait until the first transaction is going to be finished to have a valid and a consistent of the data. So the result of each transaction must be a consistent database state. And the last one, which will be durability, which is talking about when a transaction has been completed. For example, a money transfer is completed, it should remain in the system. And for example, after switching off your computer or your cell phone or the server of the bank, it should be remain there. For analytical data processing, it is basically mostly use the read-only systems to store the big volume of historical data. And basically, it can be used on a snapshot of the data or a series of snapshots that have been taken during the time. Let's just have a look at an enterprise scale of the analytical architecture. In the left side, we've got the transactional data or operational data, which is our databases or our files. In step number 1, firstly, we need to just move that data from the transactional side to analytical side, right? But we have to just collect them in a central location, and the action that we are going to do will be an ETL. ETL stands for actually for extract, transform, and load the data. And once this loading is done, it will be loaded either in a data warehouse or on data lake. So once the data is in the data lake, we can use that, to be aggregated into an OLAP or in a cube. And once that data is ready there, the data analyst is going to analyze and report based on the data in OLAP system or in the data warehouse and in the data lake. We've heard some new words here. Don't worry. We have the data warehouse, data lake, and OLAP. We will just cover them in the next slides. When it comes to the storing of data in analytical for analytical purposes, we will have data lakes, data warehouse, and data lakehouses. So the data lakes are basically referring, to a common data storage for large scale of the data, which is a file-based one. The data is going to be collected and analyzed there. And one available option in Azure Microsoft will be Azure Data Lake Storage Gen 2. For data warehouses, it is going to store the data in relational schema that is going to be optimized only for reading operations, and which we need to just retrieve the data and process them. And it is going to actually, the retrieved data is going to be used for reporting and visualization. And on the other side, we have data lake houses, which is a combination of data lakes and data warehouses. So it is going to take some features of data lake, like flexibility, that we can have different type of data and files there, and also the scalable storage, that we can store vast volume of the data. And from data warehouse, it is basically getting the features of relational querying in semantics. And sometimes for doing that, we will have to just denormalize the tables to have a better and faster reports. We also talked about OLAP. What is OLAP? It is Online Analytical Processing Model, which is basically an aggregated type of data storage, which is going to be optimized for analytical workloads. And this data, aggregations are across the dimensions at different levels. What is a dimension? Let's just give you an example. In analytical data, for example, for a revenue, of a company, the revenue amount is a measure that is going to be measured against the dimension of state or its location. So we can just drill down and drill up to view aggregations in hierarchical levels. As an example here, we have an aggregated amount for USA, which is 100. Then we can just drill down to see for California, for example, it is going to be California and something else. For example, for California we have 80, and again we can just drill down for another level, which is going to be a city like Los Angeles, which will be 50 for that one. And since the data is pre-aggregated, the queries are going to be faster and they're going to be executed quickly. And an example of OLAP systems can be a queue, that we have multi-dimensional systems, multidimensional models, and which is going to be utilized for data analytic. We just talked about OLTP and OLAP. Let's just have a quick comparison between these two to recap what we discussed. So when it comes to comparison, we should say OLTP is basically referring to the transactional data, while we have the analytical data for OLAP. We have simple queries in OLTP systems, while we have to write complex queries in OLAP. It is fast, the processing is fast in OLTP because it is an online system that has to just, respond to the request quickly, while we will have some slow queries in OLAP to do the analytic on the data. The data basically is normalized in OLTP, while we have to sometimes denormalize it in OLAP for having faster queries. Of course, the OLTP, which is an online system, keep the current data, while we have the historical data in OLAP. We have a smaller size of the database in transactional side, and of course, when we are gathering the historical data, the large of data is going to be the size of the data is going to be larger. Let's see who is going to work with analytical data in the data world. First of all, we have the data scientists who might work with the data files, even either in data lake, or even sometimes they work with the data in cubes to explore and model the data. We will have the data analysts who are going to query the tables directly in the data warehouse to just produce complex visualizations and reports. And also we have the business users who might just consume the pre-aggregated data in an analytical model like cubes to just create reports and dashboards. Thank you for watching this video, which was the last part of core data concept section. And in the next video, we will talk about Azure Data Services and an overview of key data related job roles. If you like this video and it was useful for you, just give me a thumbs up and add your comments if you have any suggestion, or if you have any question regarding what we discussed, and share it with your friends and with your network. Until the next time, take care.